My name is Uri Elzur, and I represent the Ultra Ethernet Consortium, which I'm honored to serve as the chair of the Technical Advisory Committee and was one of the folks who actually made it even happen back in the year 22. We are very honored and happy to be invited here to participate in the Ethernet Alliance TEF. We chose the name Ultra Ethernet for a reason. Ethernet represents an innovative community of spreading anywhere from providers, components, test tools, well-trained operators, and consistently it has delivered gen after gen more bandwidth at lower power at very compelling cost points. Now, the AI transition, inflection, revolution does represent an unprecedented time in our industry, and I've lived through earlier transitions as well. In this case, we are really trying to solve a true system problem. You could start from the bottom up, or you could start from the huge scale of a data center architecture and come all the way down to a component. We are going to have to address better data center architecture, rack architecture, cables, components, and cooling and power solutions. But we are here to talk about how all of this affects the network itself. And we have few networks of interest that are really used by the accelerators in order to deliver this insatiate bandwidth that is demanded by training. And we also need to understand that there are few different requirements or corners to this situation. Training is bandwidth sensitive. Inference, on the other end, is latency sensitive. And in the middle of all of this, there are big questions of topology. There are questions of what's the underlying technology that you want to use, DMA-based, memory semantics based. And if you are focusing on RDMA, which is where Ultra Ethernet Consortium is at right now as we are getting ready for our release version 1.0, you'll notice that the transport that has been designed, 25 years ago around RDMA needs to be modernized for these demands of AI. If you recall, it was 25 years ago that the industry got together in order to define InfiniBand, and we are enjoying the same moment in the industry right now with the Ultra Ethernet. The collaboration between Ultra Ethernet Consortium and Ethernet Alliance could not be over-impressed. It is critical that we get the Ethernet community to adopt some of those requests that we have for optional features that are going to help us move Ethernet forward to better address AI. UEC has made it very clear that in order to accelerate time to market, we are not asking switches to change. Existing switches could work very well for us. We are also not asking applications to change, frameworks for AI or MPI or OpenSHMEM for HPC. But the endpoint has to change for transport. Now, the switches, if you follow the Ultra Ethernet Consortium recommendation, we are putting them on this nice curve where over time they provide even more functionality with some features that we are requesting the community, IEEE, other organizations to help us support. These would include link level retry, it would include credit-based flow control, the optional switch offload that is common in other technologies. So to wrap it up, as we want to keep this short, the collaboration between Ultra Ethernet Consortium that right now has more than 90 companies, pretty much the whole industry is there, and the Ethernet Alliance and us working together at this TEF event could not have been more important and more timely. Thank you very much.